Okay, question number one. So this one was actually a little trickier than I thought it was when I first looked at it. Not really. It uses the same idea. It's just going to introduce a new word, really. And I think most of you would be able to kind of look at this, and using what you know from the PowerPoint we did before spring break, you probably could have worked it out. But let's have a little look at it then. So what we're being asked for is in fact, let's go back to the question. We're being asked to work out the maximum amount of mechanical energy converted to internal energy during the fall. Now, this term internal energy, this is where you've probably not heard that term. I don't think it was in my PowerPoint. I'm going to talk to you about what that is in a second. We're going to use the ideas we know first and go from there. So we have a 1.47 Newton base ball is dropped from a height of 10 meters and falls through the air to the ground. The kinetic energy of the ball is 12 joules as it hits the ground. So the first thing I'm going to do is I'm going to make sure I'm zoomed out. Yeah, I'm going to do at the top and the bottom. So at the bottom and at the top. Okay. For each of those, the idea remains that mechanical energy, the total energy of the object in motion, is equal to kinetic energy plus GPE, right? Well, what we know in this question is that at the bottom, kinetic energy equals 12 and GPE, because it's at the bottom, right? GPE equals mass times gravity times height. Well, if we're at the bottom, it's frozen. If we're at the bottom, okay, our height is 0, so GPE is equal to 0, right? So the mechanical energy at the bottom is going to equal 12. Now, this is where we're going to get a little bit of something different, because at the top, my kinetic energy is going to be 0, right? We haven't dropped the object yet. My GPE equals mass times gravity times height. Well, in the question, we're told that the weight in newtons, which is mass times gravity, is 1.47. Right, so mg is 1.47. That's not they didn't give us the mass. They didn't give us the gravity, they gave us the weight, which is mass times gravity. So mg is 1.47. Height is 10, so therefore my GPE is equal to 14.7. Well, if we look, kinetic energy plus gravitational potential energy at the top means my mechanical energy equals 14.7. So why then are these two different? Because how I kind of showed you it in the PowerPoints was that as one goes up, the other goes down, right? If I get higher, GPE increases and kinetic energy decreases. If you drop something and as it goes lower, GPE decreases and kinetic energy increases, right? When one goes up, the other goes down, and they should always add up to the same thing. However, in this case, we're being shown that it doesn't, right? At the top, it has a total mechanical energy of 14.7, has that potential to move, whereas at the bottom, it's only actually got this much energy. So where does it go? Well, it becomes internal energy. So the total amount of internal energy will be the potential energy, which is 14.7 at the top. Let me just kind of separate this off. 14.7 at the top minus the 12 that it actually had at the bottom. It's the potential minus the active, which is 2.7 joules. So the internal energy is 2.7 joules. That's the answer, which is answer choice 1. But what actually is that? What does that mean? Well, it just means that it had the potential to move this much, have this much energy as it moved, but it only actually had this much. So 2.7 joules of that energy was internalized. It was kind of wasted, right? So if we're talking about that energy being internalized, that could be heat. As you drop something, it might get hotter, right? So it gains some heat energy. It could be sound. It might make a noise as it falls. It's basically the same as kind of wasted energy. It's not really wasted in this case because there's no actual purpose to dropping something. So you can't really talk about useful energy and wasted energy. There's no real distinguishing features between the two. We just call it internal energy because that's what it's become. It's become internalized. So 2.7 joules is the answer.